Okay, so hello and welcome. Let's build a trading bot with Python. What you're seeing here is the base infrastructure of the bot. So we are setting up a data frame containing the coins we want to trade, the information if we're in a position, and the quantity in case we bought a particular coin. Our Python script is doing data pulls via the Binance API, implements the trading logic, and finally changes the data frame in case we are buying or selling a coin. The trading logic itself is pretty much straightforward. It's just the strategy which I tested in one of my previous videos. So in a nutshell, we are buying when the close price is above the long-term SMA and also the close is crossing below the lower Bollinger Band. If that's the case, we are placing a 98% buy limit order. We are selling when the RSI is crossing above 50. So again, I recommend to check out this video beforehand as I'm explaining the strategy here. Additionally, you will find some resources in the video description if I already covered something in previous videos. Important disclaimer, cryptocurrency and in specific automated trading is bearing you a huge amount of risk and may result in a total loss of your invested capital. Cryptocurrencies are not regulated and the Python Binance API wrapper is not official. Even more important disclaimer, I'm only providing you ideas and show you the technical implementation. You need to do your own research, assess and manage the risk based on your own risk profile and make proper adjustments. Please just see these videos as a project and don't blindly follow my scripts. Losses are part of trading, be aware of the risk you want to take. Alright, so let's get started. As you see, I already did some stuff here, so I'm running my Binance Keys notebook where I'm just storing my API key and my API secret. I'm doing that for data protection reasons, nothing more than that. We need some libraries, pandas for data handling, TA to calculate technical indicators, and NumPy for some conditional checkings. And here I'm instantiating the Binance client, which enables me to both execute orders, but also pull data from the Binance API. Next, I want to set up the initial data frame. Therefore, I need a list of symbols which I want to trade. So I'm just copy pasting that from my other screen. So these are just symbols tradable on Binance. These are of course not all symbols, so this is extendable, but it's just containing, I think, like 50 symbols which are tradable on Binance. Just note that this whole script is not working on Bitcoin, so Bitcoin is not included in this list. There are numerical reasons behind that. You have to do 1 or 2 amendments to cope with Bitcoin. Now, I want to take this list and just wrap it into a data frame and give it a name, trades data frame, use pandas data frame function, and provide a dictionary here containing the column name, symbol, and the values I want to pass to this column, which is just this list here. With that, I'm ending up with a data frame like this containing a column, symbol, and all those coins which I've defined above here. Now I want to extend this data frame with a column containing the information if I'm in a position for this particular coin here, right? So I'm just setting a column open trade here and set that initially to false because I'm not yet in any position. Same for the quantity. So I'm extending that data frame with a quantity column and set the initial quantity for all coins to 0, ending up with the data frame you saw in the very beginning. All right. And now I'm going to define a function which is doing the necessary amendments to this data frame or the necessary manipulations to this data frame in case I execute a buy or sell order. All right. So I'm going to call that change pos, and this function is, so this just change position. This function is taking a particular symbol as an argument and also an order. So first of all, I want to define what is happening if this order is a buying order. So I'm just defining if order side is buy. I just want to set the open trade value to true and also pass the quantity from the order. So let's start with the open trade value to true. So I'm just taking tradecf log tradecf symbol equals to symbol, and then I'm taking a look at the open trade column here and just set that value to true because now I've bought the asset and I have an open trade here. Same logic for quantity. So I'm checking for the given symbol, provide the quantity column here, and then just read out the orders quantity, which is called original quantity. And I'm doing a typecast to a floating value because the orders are coming in as string values. And if I have a selling order here, so I'm just covering that with else, I want to do basically the same here, but I'm just setting that to false. So if I sold, I'm not in a position anymore. And if I sold the asset, my quantity should be 0 again because I've sold the asset, right? So I'm just taking that and set that to 0 again. So again, this is the function making the right data manipulations to this trades data frame whenever an order is floating in. Now let's move on to getting historical price data to calculate our technical indicators, so to get the triggers for our strategy, the buying and selling triggers. So as I've covered this function in many previous videos, I'm just copy pasting that from my other screen, get minute data. So what is this function doing? This function is pulling price data for a particular symbol. And I'm going to take 1 minute time frame data. You can change to that if you want to trade on another time frame. It's just an example. And I'm going 200 minutes back. Why 200 minutes? Because one of my buying conditions was that the close is above the 200-day simple moving average. So I'm going to go 200 steps back here. All right. These are some data manipulations I've explained in one of the previous videos, but just quickly going over it. So here I'm just screening for the very first column containing the timestamp and the fourth column containing the close price, renaming those columns, then set the index of that resulting data frame to the time column, and then transforming the index, which is the time now, from a Unix timestamp to a human readable timestamp. And in the end, I'm just transforming the close values to floating values as they come in string values. So I'll just show you how this is working. Get minute data for, let's say, Bitcoin. I'm ending up with a data frame like this, containing 200 rows, going 200 minutes back from now on. And this is the most recent price, and this is the price 200 minutes back. All right. Let's actually store that in just a data frame. And now we are going to define the indicators. So I'm calling that apply indicators here, take a certain data frame, and then start with the long-term trend or long-term simple moving average, roll over the close column 200 steps and take the mean, just a simple moving average. And now I'm going to define the parameters for the Bollinger Bands. So first we need a 20-day simple moving average, same logic as above. So as you see, I'm just quickly going over it because I've covered that in previous videos already. So this is the 20-day simple moving average. Then we need the standard deviation for the Bollinger Bands. Use rolling 20 and then the standard deviation. Define the upper Bollinger Band. Use the 20-day simple moving average and add 2 standard deviations. So in the analysis video or in the test video, I was using 2.5, but I'm working with a 2 or double the standard deviation here. But you can also try out 1.5 or 1 or 2 or whatsoever. I'm taking 2 standard deviations, so I'm taking the standard definition of Bollinger Bands here. So same for the lower band, 2 times the standard deviation, and with that I have defined everything what I need for the buying condition, and selling condition is straightforward. I'm just taking the TA momentum functions, take the RSI, provide the close column and the RSI time frame, which is just 2 time steps here. Okay, apply indicators defined. So if I would apply that on my data frame, I would get additional columns here. So yeah, this is the long-term SMA, this is the Bollinger Band definition, and this is the RSI. So let's visualize the Bollinger Bands, that maybe this is a bit more clear. So let's just visualize the close price, the SMA 20, the upper and lower band here. And with that we have visualized the Bollinger Bands here. So this would look something like this, right? Okay, now we need the conditions. I've also covered that before. This is a bit different as before, even more simple than before. So we just want to check where the close is below the lower Bollinger Band and also above the SMA 200. So I'm defining a buying column here, which is a Boolean column containing a 1 or a 0. Use numpy where and then just check, is the close below the lower Bollinger Band, and also is the close above the 200-day simple moving average. If yes, I want to have a 1 in this column. If no, I want to have a 0. Setting condition, straightforward. Just numpy where the RSI is above 50. If yes, 1. If not, 0. Typo here. So if I'm applying this to our data frame, I will get a buying and selling column containing Boolean values, zeros and 1 values here. Okay, we have calculated the indicators, specified the buying and selling condition. Now let's move over to create a buy limit order. So let me write that down. A buy limit order needs, beside the symbol, needs 2 parameters: the price and a quantity. And both have to be calculated. Both need to be calculated. And let me explain you why that is kind of a problem, which we will of course solve here. So let's say we have a price of 16.22 here, right? If I'm placing a 98% buy limit order now and would take 98% of 16.22, I would get this floating number. But this number you cannot pass to a buy limit order. You will get an error. So what we need to do is we need to take this number and round it by the amount of decimals I'm just calling it raw price, has. All right. So let's pull a raw price as an example. Using client get symbol ticker for, let's just take ETH here and screen for the price, and we are going to typecast that into a floating value. With that, we are getting the price of ETH. Now, the idea is to just take this price, transform it into a string value, split this string by the dot, and then just take the length of the decimal. So again, I'm transforming that to a string and split that by the dot, ending up with a list containing 2 elements here. I'm just taking the length of the second element, so screening for the second element here, and then take the length out of that, ending up with 2 here. So I could define that as decimal length and then just round the raw price times the limit we want to buy for, so in our case 98%, and then provide the decimal length as the rounding parameter, right? And with that, we are getting the discounted, so discounted with 98% ETH price rounded properly. Okay, so let's wrap that all in a function. So this function we will call price calculation or price calc, which is taking a particular symbol. We are defining a limit which we are setting to 98% by default, and now we are just copy pasting what we just did. So we are just replacing this with the provided symbol, then take the decimal length, pull or define the price now, which is the raw price times the limit, so the price which we want to have, so 98% of the current price, and then we are just returning the price rounded by the decimal length. So we can play a bit around here, take a look at ETH. So we are getting this, of course, changed because we have movement in the market here. But if we are taking that, for example, for Cardano, we are getting it with 3 decimals. If we take 1 inch here, we're getting 3 decimals, and so on. This is it for the price calculation. Now let's move over to the quantity calculation. More tricky, as we have to consider 2 things here. First of all, every coin has its own minimum lot size. And secondly, the proper rounding of the quantity is dependent on the lot size. Let me explain you what I mean. So we have 2 possibilities. We have lot sizes of 0.01, 0.001, 0.x01. This is one possibility. And the second possibility is that we have a lot size of 1. There are no more possibilities than that. And we have to write a function now which is providing us a rounding of the decimal in this case and a rounding of 0 in this case. So how can we do that? We have to transform the lot size into a string again. So let's start with 1.0 here, so lot size of 1. Split the string by the dot, and we're ending up with a list containing those 2 elements here. So we have to check if the very first element of this list, this one, is a 1. So we could just check that by transforming that to a float. And then we're checking if that is a 1, because that wouldn't be a 1 if we have a 0 dot something here, right? But if that's a 1, this function should us return a 0 value so that we are rounding by 0 decimals. But if we have a 0.0, we want to check the length of the decimal. So same here, so we would just take the length of this one. So if we don't have a 1 here in the first element, we want to have the length of the second element. So we, just as an example, for 0.01, we want to have 2 decimals here. All right, and now let's wrap that into a function. So we're calling that right rounding. It's taking a particular lot size, and now we are just creating a variable, split it string, transform the lot size into a string, and split that by the dot. And now we are checking, as I just explained, we're checking if the first element is a 1. And if that's a 1, we want to return a 0 because we want to round by 0 decimals. And if that's not the case, we want to return the length of the second element. All right. So again, if I'm taking right rounding of 0.01, I'm getting 2 decimal roundings. If I get a rounding of 1.0, I'm getting a 0, right? So 0.001, getting 3, and so on, okay? So we have the rounding dependent on the lot side covered. Now let's get to the quantity calculation. And let's do that step by step before we are turning that into a function. So first of all, we need to pull information for a particular symbol. Let's just take Ethereum again. Take get symbol info, provide Ethereum. With that, we are getting a lot of unnecessary information on Ethereum. So I'm just filtering out the minimum lot size for Ethereum. And let's just store that in lot size. And I've covered that in another video. I'm just typing that down here. So I'm just looping over this info dictionary and filter out the lot size. So let me just copy paste that from my other screen quickly. So, right, so I'm filtering out for the minimum quantity here, so the lot size, and typecast that to a floating value. With that, I'm getting the lot size for Ethereum or ETH. And as you see, I'm getting this one here. And if I'm providing that to my right rounding function, I would get a rounding value of 4 here, right? Now, before I'm rounding the quantity, I have to pull the price. And I have to pull the price with my price calculation function, as I want to have the price discounted by the limit I want to buy the asset for, right? To provide the proper quantity here. So I'm taking price calc for Ethereum and get a price of something like that. And now I just want to round the planned invested amount. So let's say $50 or $100 by the price rounded with this right rounding function, right? So if I'm taking 50 divided by price, I'm getting something like that, 0.015 Ethereum. And if I want to round that properly so that I don't violate the minimum lot size, I'm just rounding it by calling this right rounding function. So I'm rounding this and provide the right rounding function. And with that, I'm getting 0.0158 Ethereum. Right? Quite many steps, so go through it step by step. I hope I could explain that quite properly here. So let's wrap that all in a function, which we are calling quantity calc. This is taking a particular symbol and an investment amount. So first we want to have the info for the symbol, just doing some copy pasting here. Change that to a symbol. Now get the lot size. Then pull the price, calling our price calc function on the symbol. And set the quantity to investment divided by our price, and then round that by the rounding dependent on the lot size. In the end, I want to return my quantity here. Okay, so let's just test that for e.g. Ethereum. If we buy 50 US dollar worth Ethereum, we would get 0.0158 by 100, 0.03, and so on, 1000. You got the point, right? So we have our quantity calculation, and now we want to define our buying function. And now we are actually creating the buy limit order here. So let's call that buy. This buy function is taking a particular symbol and an investment amount. And now we are just creating the order by using client order limit buy. and we are providing all parameters. So symbol is straightforward, just the symbol. Then the price is just calling our price calc function on the symbol, and then the quantity, calling our quantity calc function on our symbol, and the investment amount. After we have placed the order, we have to call our change pos function to make the manipulations to our data frame. So we are calling change pos, provide the symbol and the order, right? And just as a recap, now the order is being passed to this change position function, and where we have it. And now we are setting the, so in case the order is being not only executed, but the order is being triggered, we are setting that to true and also pass the quantity of the order here to this data frame. Okay, so we want to print out the order once this is happening, and with that we have defined our buy function. Sell function, even simpler than that, is just taking a particular symbol and then is executing a market order. So once the RSI is crossed, we want to just place a market order here, provide the symbol, set the site to sell, type is a market order, and the quantity is now just the quantity which is in the data frame for this symbol, which has been written to this data frame when the buying function was called, right? So we're just screening for the trades data frame where the symbol is the provided symbol, and take a look at the quantity values. Same as in the buying order, we are changing the position now again. And we also want to print out the order. All right, and now we are defining our trading function. So just calling that trader, and this is just taking a certain investment amount per coin, of course. So this is trading as long as you have USDT in your wallet, right? And we are starting with setting conditions. So we are looping for symbol in TradeCF, where our open trade column has true values. So TradeCF, of course. TradeCF, open trade is true. So these are our open trades. Then we are checking the symbol column to just access the symbol where we have open trades. And then we are just creating data frames. So we are taking get minute data on the symbol, and now we are just doing all the calculations, right? Apply indicators, then the condition check, then check for only the last row. I've explained that in my analysis video. So this is just checking the very last row for the conditions being fulfilled. And now we have to, and this is very important, we have to check two things. First, if we have a selling value in the last row, so if we have a 1 in the selling column, but also if the order is not open because we have placed a buy limit order, right? And if we are placing a buy limit order, the order is pending until this certain price we have defined is reached. So we have to check if this order isn't opened anymore, so it has actually been executed. So we have to check first, we have to check if last row sell values is 1, so this is just the column value being 1 and not, and now we're just getting open orders for that symbol. And if that's not the case, and we have a sell value here in the column, we want to just call our sell function. All right. And similar logic, so could be coded better probably. So now we are just looping over the part of the data frame where we have no open trades. So I can just copy paste this whole line here, set the value to false. And now we're just looping over the non-open trades and we're checking for the buying conditions. But before that, we have to pull historical data to calculate our technical indicators, check for the conditions, pull the or get the last row, check if the conditions are fulfilled most recently, and then we're just checking if the last row buy value is 1. And if that's the case, we're just calling the buy function, provide the symbol and the investment amount, which is provided once we are calling this function. All right. So now let's run that bot. So there are many ways to run this, right? You can write a cron job and execute this script every n minute, right? You can do this with a while loop, which I will do right now. But if you want to run that over the long term, I don't recommend to run this in a Jupyter Notebook environment. I have videos on how you are running long-term bots on e.g. a virtual machine. So basically you can have two options. You can work with the loop and then just create a no-hub task, or secondly, you are working with cron jobs. So this script is designed for working with the while loop because this trades data frame is being manipulated within this script. So we don't have an external data source where we are writing in changing positions, like I already did in some of my previous videos where I'm writing the changing positions into a file, right? So if you're working with cron jobs or something like that, you have to write the changing positions into the file and then read in the changing positions every time the script is being executed, right? So now I'm just doing it with a while loop. Let's actually use a sleeping function so that we're not doing access API calls here. So we are sleeping 10 seconds here before we are calling our trader function. And we have to do some exception handling here. So we are trying to execute this function, but somewhere you are running into that error that you don't have enough funds to buy a particular asset, right? But you want to still check if the selling conditions are fulfilled, right? So this is why we have to implement a try and accept statement here so that the script is not stopping when your funds are not enough here, right? So this is why I'm doing that. So I would place a keyboard interrupt here so that you can actually stop the script manually if you want to fix stuff, but this is optional. And then if for everything else, you're just continuing the while loop. And this is an endless loop, executing this script every 10 seconds, and then you are running over this trades df, right? So yeah, if we would start that, probably nothing is going to happen because none of the conditions are fulfilled. So by the way, you could also, if you want to know your open positions within the script, you could just print out all the open positions by just, let me copy paste that from here. You could just do it like so. But yeah, as I said, a lot of improvement potential. So an even better way, but that would just be way too much for this video, so is to work with a live data stream. I have also videos on that and implement the trading logic, but I think it's a very good starting point from here on. I hope this video was adding value for you, was interesting in the best case. And yeah, if you're interested, I would run this over like 1 or 2 weeks and tell you what are the results of this would be quite interesting, right? So yeah, leave me a comment, leave it a like, and thank you very much for watching, and I'm looking forward to seeing the upcoming videos. Bye bye.